Hi there. In the following short video we're going to look at regression in GeoGebra. Now there are two ways to do this. You can do this using the spreadsheet and then create a list of points to plot in the graph window, or alternatively you can use the built-in data package. So first let's put our data in a spreadsheet. So I'm going to go to the spreadsheet perspective. There, I've put in the set of data. Now then, I'm going to plot this data. So what I do is I select it, then I right click, and I'm going to create a list of points. Okay, now actually that's just plotted the data, but I can't see it because they're off the screen. So I can come over here and adjust the screen as we've done previously and get a decent view of that. There we go. There's my data. Now what I want to do is fit a line to that data, and to be able to do that I want to have the algebra window visible. So if you come to view and turn that algebra pane on, there's a lot of things that become available. So let's have a look at this. These are all the points that I've plotted there, and this is the list that I created from all of those points. So the list is called L1. Now if I want to carry out a linear regression, what I want to do is fit a line to this. And fit is the key word that you need to try and remember, because that's what all the commands start with. So I'll come to my input bar and I'll start typing fit, and there we can see a whole list of commands. And the one that I'm interested in here is fit line. So I'll click on that one there, and it wants to know the name of the list of points. Okay, so this is called L1. To get that I type L underscore and 1, and there we have it. We have our line, and we even have our equation here, which we can even drag onto the screen. Now the great thing about this is it's dynamic, so that means that I can edit the points and the graph will change, and so will the line dynamically. So let me just change the x coordinate of that first point. You notice that the point shifted and the line changed also. It's also dynamic from within the graph, so I can pick up these points and then move them around. Okay, so probably what you want next is Pearson's correlation coefficient. So again, I need to use a command for that, and the keyword is correlation coefficient. If I start typing that, there it comes up. So correlation coefficient from a list of points. I just select that one there. It's the same list, of course. So L underscore 1, and there is my value. And of course I can drag that onto the screen if I want to display it, although if I do that it calls it A because that's the name of it, and perhaps I want to call it R. So what I could do is create some dynamic text with that. There's R, and oops, is equal to, and it's this value of A that I need to go and find from my list. There it is. Now we can have that on the screen. And as I said, this is all dynamic. So if I go and change one of the points there, let's try this one, and I'll try and make that value be closer to -1. The line change, the points change, the line changes, and Pearson's correlation coefficient changes also. Okay, so I want to just explore some other functions of this, some other commands. So I've just changed that data, and it no longer seems to fit perhaps linear function so well. So I'm just going to change this. So I'm going to delete this line and also the correlation coefficient there. And what I'm going to do is I'm going to try and fit a different type of function. So again, type fit. And you may have noticed that there are other sorts of functions you can fit to that. So there is, well, let's have a look. An exponential model, there's a growth model, a line we've seen already, we've got a logarithmic, a logistic, a polynomial, which might be useful here, a power function, and we've even got a trig function also. So if I go to polynomial there, I'm going to type in what's my list, so L underscore 1, it's still the same one. What's the degree of my polynomial? Well, it looks more like a quadratic to me, so let me type 2. There we go. And that seems to fit quite well. So how does it fit? Now, if I want to see how well it fits this data, then I'll probably want the R² value, the coefficient of determination. And how do I find that? Well, easy. I just start typing R². So R² there. My list of points, as before, is L_1, and the function is the name of that function, which is f. There we have it, and my R² value is 0.99. Right, the last thing I want to show you is the built-in function of the statistics mode. So let me just get rid of what we've got on the screen. Right, so the first thing we've got to do is come to the spreadsheet perspective. We click on that, and then we enter our data in. We select the data, and then we come to two-variable regression analysis. We click on that, and then it plots our data. Now we need to select the correct model, so I'm going to go for a linear model here. There's lots of other ones that are built in, and if I just click on that, it displays the equation here. I can do calculations for the y value if I know an x value. I can even swap which is my dependent with my independent variable, so I can do x on y regression tool analysis by clicking that. And I can also display the summary of statistics, which is really useful if we want to get the product moment correlation coefficient.